This is a review of Chapter 22, the respiratory system. In Section 1, it discusses the purpose of respiration, which is gas exchange. Gas exchange is how oxygen gets into the body, how carbon dioxide gets out of the body. The purpose is because of cellular respiration. Cellular respiration requires oxygen, produces carbon dioxide. Now, a gas exchange surface is the part of the body where gas exchange occurs with air or water, depending upon what kind of critter we're talking about. The gas exchange surface or respiratory surface must have enough surface area to handle enough diffusion of oxygen for the body. And it must be wet because you can't get diffusion through a dry membrane. Sections 2 through 4 discuss animal gas exchange structures. Earthworms use the skin, known as cutaneous respiration. It uses its entire body surface to breathe from. Gills are respiratory surfaces in water. A gill is typically an extension of the body surface. So for example, in Section 3 it shows the fish gills. Now fish gills have blood flow inside of the gill, which is counter current to the water flow outside of the gill. It maximizes oxygen diffusion that way. Now gills don't work well outside of water because they are prone to drying out and because surface tension will collapse the gill filaments. So to breathe outside of water, the respiratory surface needs to be inside the body, a folded internal surface rather than an external surface. So for example, insects breathe using tracheae, tiny tubes that stretch throughout the entire body. That's in Section 4. And we, of course, vertebrates, use lungs. Section 6 discusses the human respiratory system. Be sure to look at the diagram and the drawings and the labels of the organs. We start off with the nasal cavity. We can breathe through our nose as well as our mouth. The pharynx is behind both of them. It's the common pathway for the respiratory and digestive tracts discussed in the digestive system. Same pharynx. The respiratory tract leads to the larynx, the voice box area in the throat, which then leads to the trachea, which then branches into the right and left bronchi, which enter the lungs. As they branch further, they become terminal in the alveoli. They end in the alveoli. Now, this is where the gas exchange surface occurs, in the alveoli of the lungs. Now, blood flow, of course, occurs there. Be sure to study the diagrams. Now, Section 7 basically discusses the effects of smoking on the respiratory system. The tar can cause damage to the lungs. The carcinogens in tar can lead to lung cancer. Be sure to read this section. Sections 8 and 9 discuss the physiology of breathing. Section 8 discusses negative pressure breathing. What happens to breathe, to inhale, you have to contract the rib muscles and the diaphragm. That expands the lungs, increases the lung volume. And when you do that, it decreases the air pressure inside the lungs, creating a partial vacuum. Air moves in. When you breathe out, the rib muscles and diaphragm relax, lung volume decreases, air pressure in the lung increases, and air moves out. Now, this is automatically controlled. Section 9, you have breathing centers in your brain stem, the pons and medulla oblongata, which send nervous impulses to the breathing muscles at regular intervals. And that's what automatically controls breathing. Now, you have chemoreceptors in your blood vessels so that if, for example, you're exercising, it sends the signals to the breathing centers to increase your breathing accordingly. The last sections deal with gas transport. Oxygen has to diffuse from the air into the alveoli, into the blood where it binds to hemoglobin. So hemoglobin carries the oxygen in the blood to the tissues. Now at the tissues, they're producing carbon dioxide. Now carbon dioxide does actually react with the fluids in the tissues to produce carbonic acid. So that slight lower in pH value at the tissues forces hemoglobin to let go of oxygen, and now oxygen is free to diffuse into the tissues. Now for carbon dioxide, it's transported in the blood in three ways. Some of it, a small amount, is actually dissolved in the blood plasma and it diffuses out of the lungs. Another small percentage of it is actually bound to hemoglobin and it also diffuses out at the lungs. Most of the carbon dioxide in the blood, however, is converted into the carbonic acid bicarbonate pH buffer to balance the pH of the blood. So be sure to study your notes on these matters.